Hi everyone, thanks for joining our webinar on water utilities, industrial Internet of Things. Today who will be presenting is Young Hao Lin, and he's a principal engineer with us. So as always, if you have any questions, feel free to type them into the text box on to the right. And without further ado, here is Young Hao.
Hi everyone, thank you for joining the webinar. So today I'm going to talk about water utility IoT field experience and how Cambian networks fit into this space. The agenda, so I'm going to talk about IIoT architecture. What is IIoT? And how does Cambian network fit in? And then I'm going to talk about Cambian Network's IIoT product portfolio, and finally I will talk about our IIoT with water utility experience. So let's take a look at the water IIoT system architecture. So what is IIoT? IIoT stands for Industrial Internet of Things. So when we talk about Industrial Internet of Things, it's different from typical people thought about IoT. For example, like residential, like smart home, things like that. It's more about industrial. For example, things like water utility, like oil and gas, like mining, industrial. That's the kind of industrial IoT, the Internet of Things that we're talking about there. So it's industrial Internet of Things. So there will be things and there will be network. So the things will be connected by network. So how does it look like? So when we look at the things could be different kinds of sensors and all controllable devices, and including so these things will be connected by the network to the control system, such as SCADA or any like programmable logical controller, like PLC. So when we look at the things, what kind of things do we have? In the water utility space, there could be like temperature sensor, like a pressure sensor, like a water level sensor, etc. And also there will be things like pump, like valve. So how does these things communicate to the control system? The things, the sensors will sense will measure its required measurement data, and then it has to convert it to something that can be interpreted. For example, it's very typical that the sensor will generate output such as electrical voltage, electrical current, some dry contact on and off, impedance. For example, like you can have a temperature measure sensor, a temperature sensor that will measure the temperature, and at the end it will the outcome will be different level of voltage. You can have a pressure sensor, and depending on the level of the pressure, it will generate a different level of current. Or sometimes it could be impedance. For example, you have a light sensor. The light sensor may, when you cover the light sensor up, it does not sense the light, and it may result in low impedance. And when you let the light in, it may result in high impedance, and so on. So this kind of output will be typically have to be processed. It can be connected to an I/O device, and this I/O device would know how to interpret the voltage, the current, the dry contact on and off, and the impedance. So the I/O device can be, sitting there and smart enough to handle query from the SCADA system or PLC. For example, the I/O device, the I/O to IP device can act as a Modbus TCP slave, and then the controller, such as the SCADA master, can send a Modbus TCP request to query certain sensors data, and the I/O to IP device will just respond. And also, let's say in case of automatic control, like using PLC, the PLC may make some smart decision. For example, let's say if the water level is too high, so it's actually when you use the Modbus TCP to query, it figure that the water level is too high. The PLC may send a command to the this I/O to IP device to shut down the pump, or actually start pumping water out of the tank, depending on your setup. Traditional connection will typically actually use the remote terminal unit. So what I'm saying here is that the things can connect to the I/O to IP device, or it can connect to the RTU. This RTU will typically has a serial interface. So to connect to the internet, the serial interface need to be converted to IP. So you would throw in a serial to IP device, which convert the serial traffic into IP and be carry over the network, and then convert it back to serial if the SCADA master happen to use a serial interface, which traditionally that's the case. Okay, so and then so now we talked about the thing. So what about the network? So once you convert the things signal into IP, now you have a network that will connect the things. So what kind of choices do you have? You can certainly have Ethernet cable, but that requires changing to the ground or some cabling setup, which might be very costly, especially when you have to have a longer distance between the things and the controller. And you can use wireless broadband if you are able to get very good line of sight. You can use wireless narrowband. This wireless narrowband is typically used for situation where you cannot have clear line of sight. For example, like you have to traverse foliage and things like that. And in terms of the protocol in this water IoT system, you have Modbus TCP, you have DNP3, you have Modbus RTU, you can even have MQTT, and so on. So keep in mind that automatic water control system actually exists before the IIoT concept was introduced. So traditionally, here's how it looks like. You still have the things, but typically these things will be connected to a RTU, and to connect to the SCADA controller or PLC, you use serial line such as RS-232, RS-485, and RS-422. So there's a limitation to this serial protocol, of course. For example, like RS-232, it can have a maximum distance of only 50 feet, which is very short. And so if you're doing that, that means that the RTU has to be very close to the SCADA master. So you cannot deploy a remote SCADA controller. So for longer distance, you can have RS-485, but RS-422. RS-485 and RS-422 allow longer distance. The maximum distance is 4,000 feet, which is still somewhat not very long, but it's better. But the problem is that all these are cabled systems. So I talked to a few customers of ours in the water space, and the biggest cost actually is not about the things, the cost of the things or the SCADA controller. It's more about spending the effort and human resource and the labor to change the cables under the ground. So this is the most costly thing. So now let's think about that. With the IIoT introduction, you are much more flexible and much more cost effective, because think about wireless. If you are using wireless technology, you actually can allow the things to spread on a much bigger distance, and you just need to hook up the radios and let them talking to each other. You don't need to change the ground. You don't need to worry about, okay, what if somebody happened to dig into the ground and damage your cable, to lose your connection. So there's a huge advantage to use wireless network for the SCADA system. So here's the IoT. So now let's look at how Cambium network can help you enable your IoT. Obviously, Cambium network does not involve, we don't want to get into the things itself because it's very specific to different kind of industry. What we are offering here is for you to connect the things to the network so that we can actually hook you up from things to the controller. So let's look at this. So with the if you are using you have some traditional SCADA system, you will connect your things to the RTU. You can use a Cambium cnReach to convert your serial data into IP, and then this serial data can now be carried over our wireless broadband network. And then when it reaches the other end, you use the cnReach, which support IP to serial, to convert it back to a SCADA. So if the SCADA must happen to run over a serial interface. So in terms of wireless broadband, we have a broad range of products to choose from. For example, the very high capacity PTP-820 licensed microwave. I'm going to talk more detail later. We have PTP-700. We have PMP-450 for point multi-point, and we have the lower cost ePMP and the Wi-Fi based CN Pilot, which give you very short range, but it's very easy to use. Now, if you happen to need, if you need to connect things, and you have to traverse near non-line of sight, such as this, foliage and things like that, you can use our wireless narrowband product, which is still under the cnReach platform. In addition, our cnReach platform also support I/O to IP conversion. So you can actually directly connect your things to the cnReach I/O module. So now the cnReach I/O module will take the voltage, the current, the impedance, the dry contact, on or off switch into the I/O module, and make it ready for query by the SCADA master or PLC. For example, the cnReach actually can act as a Modbus TCP slave. So you can have the PLC query the things data, for example, temperature, water level, and pressure, and things like that. And also the PLC, once it get the data, it can make a decision on whether to shut down a pump or turn on to move the valve or what have you, etc. Still, we support the same kind of protocol, Modbus TCP, DNP3, and the Modbus RTU. So now let's say if you are deciding to deploy water IIoT with Cambium Gale, Cambium product portfolios, you can do a lot of things. Not just IIoT, but there's some other thing you can do. So in terms of IIoT, you can now enable your IIoT. You can support water meter aggregation backhaul. You can support SCADA process control monitoring, which we already talked about. In addition, you might have additional bandwidth to support something like remote access control, video surveillance, which consumes a lot of data, bandwidth. You can even replace your lease line, which would have been really costly, but now you have this wireless broadband at your disposal. So you can do lease line replacement, and you can even set up remote office connectivity using the wireless broadband. So if you look at the picture below, here we gave you a very good example. For example, on the right-hand side, you have several video surveillance camera. So this video surveillance camera the video can be backhauled by our point-to-multipoint product, like the PMP450. And also, you will have some SCADA PLC, and that can be done using Wi-Fi, or sometimes, and then on the bottom you have digital water meter aggregation and SCADA data. You might, depending on your deployment environment, you may use the cnReach that operates in the sub-gigahertz band. And then once you get all those data, you will use point-to-point product like either PTP 700 or sometimes even like PTP 820, which has a huge capacity. So this pipe will aggregate your data, and then eventually you can form a ring, such as a microwave ring that operates in the licensed frequency, and then you connect to the network control center. So the key takeaway is that Cambium has a broad range of product portfolio for you to choose from to deploy your wireless water IIoT, depending on your application. So now let's get more deeper into our product portfolio. So you can see that on the left-hand side, we have this licensed microwave backhaul, the PTP 820, which operates in the 6 to 42 gigahertz range. It has very high capacity. It can provide more than 1 gigabit per second of data throughput. And then we have this unlicensed sub 6 gigahertz backhaul. That's the PTP 650, PTP 450, which operate from 900 megahertz to 3 gigahertz to 5 gigahertz. And then we have this photo multi-point for you to do aggregation and access and video surveillance. So this PMP 450 operates also in the 900 megahertz, 3 gigahertz, and 5 gigahertz. And then we have this Wi-Fi access hotspot. That's a Wi-Fi based AO 2.11 AC based E500 operating in outdoor environment. And if you have to use non-line of sight, we have this cnReach product line, the N500, which is introduced recently, that operate from 450 megahertz to 900 megahertz. We are going to have some lower frequency radios down the road also. So you see this product portfolio, you can imagine Cambium actually allow you to have a range of, basically we say the range that you can have is from a few meters to 200 kilometers. So that's the range. In the 200 kilometers, we have one link that deployed with 200 kilometers of range and works very nicely. Okay, so in terms of the frequency, you can operate in the narrow band all the way to 42 gigahertz broadband, high frequency, low frequency to high frequency. In terms of the data rate, the narrow band radio tend to have low data rate, and the broadband radio tend to have high data rate. We actually give you a few kilobits per second all the way up to more than a gigabit per second. So you see, we are very, we give you extreme capacity, unparalleled scalability, low cost, very flexible, and low complexity, very easy to maintain. Keep in mind that all these products can be managed by our cloud-based CMSO platform. And when you want to design your network, you can use our free software, the Link Planner, which is very helpful for you to design your network, to understand your link budget and understand your availability given the environment.
Hey, Young Hao,
yes.
There's actually one question, and you might not be the person to answer this, but I'll try anyway.
Okay.
The cnReach 450 meg, do you know when that will be available in Link Planner?
It's going to be available within like 2 weeks. We are actually working on that. 2 months. We are working on that.
Okay.
Yeah.
Cool. Thank you.
So you see, in terms of line of sight, non-line of sight, we support non-line of sight, near line of sight, and clear line of sight. Obviously, the narrowband product is for non-line of sight, and microwave is for clear line of sight. And you get different kinds of latency. I mean, you get different kinds of application to support. For example, like video, data, voice, and control. And naturally, this product portfolio can be deployed worldwide in different regions. So let's dig deeper into our cnReach platform. The cnReach platform is introduced specifically to serve the need of the IIoT, not just for water, but for the whole industry. And the reason is that this cnReach product is very easy to deploy, especially for non-line of sight environment. I'm not saying that you have to use narrow band for IoT, as you can see before. If you get the IF environment that allow you to do clear line of sight, you would do much better using wireless broadband, because that gives you much more bandwidth and better throughput. But in terms of when you consider cost and when you consider your deployment environment, you may end up having to deploy narrowband product. So there you go. You have this cnReach platform to help you implement your network. So overall, the cnReach platform, we have different multiple models. So these different models, they will support a different frequency band. So there will be a 900 megahertz radio that support licensed and unlicensed. And we have a 700 megahertz licensed radio. And we also have the 400, 450 radio. That's for global. And the radio comes, the unit comes with a single radio port and dual radio port. It's your choice. Sometimes people say, okay, I need one radio port. You get one radio port. You can get two radio ports if you think that you need two radio ports. And also, this radio comes with the I/O option. Remember, in the previous slide, I talked about you connect your things to an I/O converter, I/O to IP converter, and that's it. If you purchase the optional digital analog I/O option, you can connect the things to this the green port. I mean, on the left-hand side, and then the radio will serve as a Modbus TCP slave, and you can use any Modbus TCP master to poll the radio to get the things reading, and you can even send control messages, still Modbus TCP control messages. Say, for example, you can, send control message to shut down a relay pump, or power up a pump, things like that. In terms of reliability, this product is very, very reliable. Number one, this product is made in the USA, and number two, we are 100% factory tested over temperature, and we are certified for ATEX and HAZLOG. So this ATEX and HAZLOG allow the device to be deployed to special chemical location, the location that require this kind of certification. The power consumption of this product platform is very low. The good thing about this power consumption, low power consumption, is that you can deploy this radio in an environment where you cannot find direct power, so you might have to ending up using solar power. So low power consumption make the cost lower when you have to use solar power. And it's very scalable. We support different modulation mode, and we support adaptive modulation mode. And the other thing is access point synchronization. What does it mean? That means that you can deploy multiple overlapping unlicensed network, all sharing the 900 megahertz band. But you can, because of synchronization, each radio can be operating in such a way that they will not interfere with each other. Also, we support a security feature, this 128 to 256 bit AES encryption, and this is very useful. As we know, I mean, Modbus TCP is all open. It's clear text over IP, so you cannot hide. So what do? You want to encrypt your data over the air so that you don't get hacked. For example, let's say if you don't encrypt your data and some bad guy is able to sniff the traffic, he or she can actually modify the Modbus TCP packet. So instead of, let's say, you want to shut down the pump, this guy may intercept your packet and modify it in such a way that it requires the pump to turn on. that will cause a disaster. So security is important, very important. And this radio is manageable using our cloud-based or NUC-based cnMaestro platform. And if you want to design your network, you can use link planner to plan the link budget, so on. So now to each product. So this one shows the 450 megahertz narrowband radio. You can look at, we operate in the frequency range of 406 to 430 megahertz, 450 to 470 megahertz. In terms of power consumption, in terms of power output, we operate up to 8 watt for FCC and 2 watt for ETSI. And the channel size can be 12.5 to 25 kilohertz. In terms of the capacity, it's given the channel size is low capacity, but it's up to 102 kilobits per second for ETSI, 76 kilobits per second for FCC. And we support up to 64 core modulation mode. The range is 17 miles. Again, this radio is equipped with optional digital analog I/O, but it's standard with two 100 Ethernet ports and 2 serial ports. These 2 serial ports can be used to manage the radio, or it can be used for IP, serial to IP, IP to serial conversion. Oh, actually, sorry, I need to show. I need to show this. Actually, we have some other product which I happen to hide it away. So okay, so this slide. So and then you look at our 900 narrowband radio, 900 megahertz narrowband radio. So we support both MAS licensed and ISM unlicensed using the single model. You can configure the radio to run on the licensed, band or on the unlicensed band. For the license, we support, given the low small channel size, we support up to 210 kilobits per second, and modulation mode is 32 core. ISM unlicensed, that's much more powerful with a channel size of, so it's actually frequency hopping based, and it supports from 57 kilobits per second up to 4.4 megabits per second. Keep in mind that this 4.4 megabits per second is raw data rate. It's over the air data rate. But when we're looking at the user data rate, you still get like 2.5 megabits per second, which is still very good for a narrowband product. Again, range is the same, 70 miles, and encryption, security, and the I/O interface. We have this standard 2 Ethernet port and 2 serial port, and optional digital analog I/O. And so keep in mind that all this radio can have dual radio port or single radio port. And we have this 700 megahertz narrowband radio. Same thing, different capacity, different channel size. And this one, again, it can do single radio port or dual radio port. The maximum capacity is 1 megabits per second. We talked about cnReach 450 already. So in case you you don't need narrowband. What do? But you still want Internet of Things. You still want to connect your things to the network. You actually have an option. That's to use our cnReach I/O expander. You see, this radio does not have a this device now. So not quite radio. This device does not have a radio port. It's the same form factor. It just does not have the radio port, so it's much cheaper to purchase. The sole purpose of it is to provide serial to IP or IP to serial conversion, and also you can use it to do to connect your things to the digital analog I/O port. So you can connect your pump, your sensors to this green I/O port here. We have 8 channels on the I/O port. So you can connect to them, and this device will act as a Modbus TCP slave to to allow control by a Modbus TCP master. The power is 10 to 32 volt DC. In terms of deployment topology, this cnReach platform is very flexible. Same model, same unit, you can configure for different kinds of topology and different kinds of role. For example, you can configure 2 radios as a point-to-point link, and you just hook up a Yagi antenna on each end, and you're good to go to have a point-to-point link. Or you can form a coverage network by setting up one of the radio as an access point, and then the other radios could be endpoint. In situation where you cannot have a good shot without a relay, you can set up one of the radio to act as a repeater. So we have 2 choices for a repeater. So for example, you have to, the signal has to travel, go past a building. That would be difficult, right? So you can actually set up one of the radio as a repeater so that it will allow the signal to, go around the building to the endpoint. So there's 2 options. You can use store and forwarding repeater, which is cheaper. That's a single radio port, which is cheaper but with a lower efficiency. And you can use the dual radio back-to-back repeater, which is more expensive, but it's much more efficient in terms of RF efficiency. Of course, it's more costly. And then out of the repeater, you can still connect to your endpoint. So all these Cambium products can all be managed by one single platform. That's the beauty. I mean, you can manage PTP, PMP, EPMP, cnPilot, cnReach, or under the cnMetro platform. So it's an end-to-end management system. So you can see that you can use one single pane or glass to manage the whole thing. You can map the location of the devices. You see, look at this. This is a screenshot of deployment. So we have a site, a certain location, and then this GUI also shows you the hierarchy. I mean, which AP is connected to which endpoint, and so on. And it gives you performance statistic tracking. You can push password change to, you can actually, let's say if you want to change password of all the devices in the network, you would be able to do that. You can actually push a password change, which will trigger in all the radios to change the unique password. And it give you alarm, different kinds of alarm, different levels of alarm, critical, major, and minor alarm. Give you firmware upgrade capability and capacity management. So now let's look at one of the deployment, our recent deployment for one of our water utility customer. So this water utility customer is the Coulter Water Management District in Ohio. You can see from the network, the picture here, we use Link Planner to help this customer plan the network. This network contains 33 radios operating in PTP and PMP mode. So what's the problem that this customer tried to solve? So this customer, this water management district in Ohio, they serve a population of 30,000 residents surrounding the area. They're already deploying wireless network for their SCADA control system. So they have been using 900 megahertz unlicensed frequency. The problem is that this customer, the operating location is very close to Air Force base, so they constantly have interference. So after studying the situation, they decided to, we actually advised them to run overlapping of 900 megahertz unlicensed and the 700 licensed overlay, so that you can get the critical data over the 700 network. The thing is that this customer cannot afford to lose any bits, if the SCADA message does not pass through. I mean, the water quality would be, suffer. I mean, you don't get to, let's say, okay, you need to put in some chemical, and if because of the control signal does not go through, the chemical will not be put in, or water pressure could be too high or too low. There's a lot of consequence if the SCADA control data does not pass through, and that's why the customer decided to move with us to use the 700 megahertz license coverage. So you can see we actually set this up, and on the left hand side you can see bucket truck installing the radio device on the rooftop, which is very simple, right? You can see that you just need to put on a Yagi antenna there, and there you go. You put the radio in the radio is in rail mountable, so you put it in a enclosure, you're good to go. So this particular customer, they were using 900 megahertz unlicensed, and interestingly, they have traditional interface for the RTU, so it's serial line based interface. So they're happy to have this cnReach because we have this serial to IP converter, which allow the serial interface data to be converted to IP. So now they can achieve all IP based control. So they use Link Planner obviously to design the link at the network, and it was quite successful. And in terms of the coverage, they have some places which have foliage, and they were able to do like 2 miles of range because of the foliage. So that's one of the successful deployment case. I think we are running very close. So for this other example is a wastewater treatment plant in Colorado. I want to show you the enclosure setup. I mean, just show you how simple it is to set up this cnReach radio, because it's very small form factor. You see that this cnReach radio with it's mounted on a beam rail in the enclosure, and then you just pull a cable to the cnReach and all the way up to the rooftop. Use a Yagi antenna, you're good to go. And you can actually have some other I/O devices in the enclosure. So this is what it looks like on the left-hand side. The house that we have the cnReach installed, and then you can see that the Yagi antenna is on the rooftop, sticking out. So that's another use case in wastewater treatment in Colorado. So this concludes my presentation. I want to follow us. We have multiple social media sites you can follow. We have Facebook, LinkedIn, and Twitter, and Google, and even Weibo for Chinese customer. And last but not least, it's very useful if you have any concern, any question, you can log into our community forum. Keep in mind that this community forum sometimes can be very quick in reacting to your request. For example, if you have non-standard request, you can go to us, because if you have a question about the product or something, you may go to our support team, which is very helpful. But sometimes you have some question about network design, how to implement certain thing, which is which requires more technical thought and design skill. You go to our website, you post the question to the forum, and this forum is actually being monitored by the technical expert in our company. So each technical expert are assigned to spend like half an hour a day or so to look at the website to see if there's any help asked by our customers. So just feel free to post your questions or your suggestions or wherever in the forum, and we can all try to help, or we can actually work together to make this product better. So thank you very much for attending today's webinar.
All right, thanks, Young Hao, for giving that presentation. And if anyone's still listening, thinks of any questions a little bit too late, as Young Hao mentioned, you could just post them to the forum, and we will get to them within a day. Or you can get a response from the current Cambium owner as well. With that being said, have a great day.
Thank you.